Good morning, children, and welcome to today's online session. Let's begin our class with a be not idle, to the best of which you are capable, then accept whatever happens. That is the way to peace. I repeat my thought, children. Be not idle, to the best of which you are capable, then accept whatever happens. That is the way to peace. So, children, do not be idle, and you have to do maximum how much is to your capabilities. Then later you can accept whatever happens. Then that leads to peace. Okay, so in the previous class, what did we learn, children? We've learned till exercise 10.3 till fifth problem. So let's continue with exercise 10.3 in today's session. Moving to the sixth problem in exercise 10.3. A tabletop measures 2 meters by 1 meters 50 centimeters. What is its area in square meters? So they are saying a tabletop measures 2 meters by 1 meter 50 centimeters. What does it mean? See, 2 meters by, that means they're giving the dimensions, that is length and its breadth. So 2 meters is its length and 1 meter 50 centimeters is the breadth. And what are they asking to find out? They're asking to find out the area in square meters. So we know the length, we know the breadth. So how is the length and the breadth? Are they same or different, children? They are different. So what could be the shape of the tabletop? Yes, that is nothing but rectangle. If the dimensions are same, then it should be a square shaped tabletop. But here, since the length and breadth is of different dimensions, then we can say that this tabletop is of rectangle shape. So what is the area of a rectangle, children? Yes, it is length into breadth. So let's begin to solve the question. Yes, what is the first statement, children? Length of a tabletop is equal to 2 meters. What is the breadth of a tabletop? 1 meter 50 centimeters. 1 meter 50 centimeters, we can write it as decimals in meters. So we have learned that in decimals chapter, children. So 1 meter 50 centimeters can be written as 1.5 meters or 1.50 meters. So what is the next statement? Area of the tabletop. Area of the tabletop, since it's a rectangle tabletop, the formula is length into breadth. So what is the length? 2 meters multiplied by 1.5 meters. It's nothing but 3.0 square meters. So what is the units of area, children? It is square meters. Please don't forget to write the units, right? So next is therefore area of the tabletop is 3 square meters. So I hope you understood the sixth problem. Let's move on to the seventh problem. A room is 4 meters long and 3 meters 50 centimeters wide. How many square meters of carpet is needed to cover the floor of the room? So they're saying a room is 4 meters long and 3 meters 50 centimeters wide. So how many square meters of carpet is needed to cover the floor of the room? It's similar to a previous sum. So you can complete that as a homework. Let's move on to the eighth problem. A floor is 5 meters long and 4 meters wide. A square carpet is of side 3 meters is laid on the floor. Find the area of the floor that is not carpeted. So what are they saying, children? A floor is 5 meters long and 4 meters wide. So the length of the floor is 5 meters and the breadth of the floor is 4 meters. And a square carpet of side 3 meters is laid on the floor. So you can imagine the floor, children, and you can also imagine a carpet placed on the floor. So find the area of the floor that is not carpeted. So we are not placing the carpet all over the floor. We're placing the carpet only to a small amount of space of the floor. And they are asking the area of the remaining floor which is not carpeted. So I hope till now, by now you have imagined what exactly the question is about. So let's see it through a figure. So if this is the room floor, which is of 5 meters wide and 5 meters length and 4 meters breadth. So in this floor, we are placing a carpet which is 3 meters side, and that is a square carpet. So in a square carpet, all the sides are equal. So 3 meters by 3 meters. So what is the area of the floor that is not carpeted? So can you see this figure, children? The blue area is the floor, and to that blue area we are placing a carpet which is in yellow color. Just an imagination, children. So this carpet is placed which is 3 meters by 3 meters. So what is the area which is not carpeted? It's nothing but this blue area. Now how do we find that, children? Yes, if we find the area of the floor and then the area of the carpet. We need to find the area of the floor and the area of the carpet. And then from the area of the floor, if we subtract the area of the carpet, then we can know the remaining space area. I hope it's clear, children. Let's solve it now. What is the first statement? Length of the floor is 5 meters. Then breadth of the floor is 4 meters. Then we have to find the area of the floor. So area of the floor is in the rectangular shape. So length into breadth, which is 5 meter into 4 meters. That's nothing but 20 square meters. Next, we have to find the area of the carpet. So what is the side of the carpet? The side of the carpet is 3 meters. It's a square carpet. So we don't have to find another breadth. All the sides of a square carpet is of same dimensions. So that what is the area of the square carpet, children? The formula is S into S, which is equal to 3 meters into 3 meters. What is 3 threes are? 9. So the answer is 9 square meters. So what did I say in the beginning? From the area of the floor, if we subtract the area of the carpet, we will get the area of the floor that is not carpeted. So how do we do that? Yes, it's the area of the floor not carpeted is equal to area of the floor minus area of the carpet, which is nothing but 20 square meters minus 9 square meters, which is equal to 11 square meters. So what is the area of the floor that is not carpeted? Therefore, 11 square meters is the floor which is not carpeted. Okay, children. So let's move on to the next question. I hope you understood this question. Let's move on to the next question. Ninth question. 5 square flower beds, each of size 1 meter, are dug on a piece of land 5 meters long and 4 meters wide. What is the area of the remaining part of the land? What do you understand by this, children? Can you just think that it is somewhere similar to the previous question? Yes, that was the floor. Here it is a piece of land. That's the difference. So let's repeat the question once again. 5 square flower beds, 5 square flower beds, each of side 1 meter, are dug on a piece of land 5 meters long and 4 meters wide. What is the area of the remaining part of the land? So how do we get it? See, this is a piece of land which is 5 meters long and 4 meters wide. So inside this we have a flower bed. How many flower beds, children? It's 5 flower beds, which is 1 meter by 1 meter. Similar to the previous sum, this is also a square flower bed. So the dimensions of length breadth are same. So we only have the side. So how many such flower beds are placed? 5 such flower beds. What is the area of one flower bed, children? Since it is 1 meter by 1 meter, what can you say about the area of this flower bed? It is 1 ones are 1. So area of one flower bed is 1 square meters. So what is the area of 5 flower beds? It is 5 into 1 square meter, that is 5 square meters. So you know the area of 5 flower beds, and can you find the area of this land, children, with the dimensions of 5 meter by 4 meters? Yes. So from the area of the land, subtract the area of 5 flower beds. We get the area of the remaining part of the land. This, I hope you all can do it as homework, children. Complete it as today's homework. Now let's move on to the question. 10th question, children, we are omitting it. So just leave the 10th question. You can put a cross mark beside the question. Just leave it. Is it clear, children? Let's move on to the 11th question now. Split the following sheets into rectangles and find their areas. Children, now just think over. We have learned in grade 5 how to find the area by splitting the figures. I hope you will recall that by seeing this figure. Yes. Just observe your textbook, children, at question number 11. We don't have this line in your textbook. So we have a L-shaped figure and they gave you the dimensions. So that L-shaped figure is not a perfect square nor a perfect rectangle. So we can't find the area of such figures directly. So what do we do for such figures? We need to split the figure into different parts and then find the area of each part and then add all the part area, we get the final area of the figure. So here this is an L-shaped figure. I've divided into two parts. So what is this? This is figure 1. This is figure 2. So now what is the length of this figure 1? 10 meters. What is this complete length? 12 meters. So this figure I'm splitting into two parts. So I'm drawing a line here. So if from here to here is 10 units and then from here to here is 12 units, then we know that till here it is 10 units. So total 12 minus 10, what will be this part, children? It will be 2 units. And similarly, this complete part is 10 units and this part is 8 units. So 10 minus 8 is 2 units. So we know that this is 2 units and this is 2 units. We need to find the missing lengths after dividing the parts. That is our first step. First step is divide the figure into different parts, and then after dividing, the second point is you need to find the missing dimensions in the figure after separating. Now, can we find the area of this figure, children? What will be the area of this figure? 10 into 2, that is 20 units, square units. And what will be this? 10 into 2, that is 20 square units. 20 plus 20 is 40 square units. So this you complete it as homework, children. Let's move on to the B bit. Now look into this picture. Yes, it looks complicated, children, but it is not really complicated. See, they've given you a figure which is looking just like a cross. So what can I do with this figure? I have to divide it into different parts. How do I do? I can draw a line here. I can draw a line here. I can draw a line here. And I can draw a line here. So after drawing the lines, the figure will look something like this. So what do we know? That this is one part, this is the second part, this is the third part, fourth part and the fifth part. So we divided this whole figure into 5 parts. So what can you say? This is figure 1, figure 2, figure 3, figure 4 and figure 5. So can we find the area of these figures separately? So now this is 7 units, this is 7 units, this is 7 units. So this is similar to this. This line is similar to this side. So what can you say about this side? This also is 7 units. And this is 7 and you can see that this line is also 7 units. And if this is 7 units, this is also 7 units. This is 7 units, this is also 7 units because all the shapes is something like a square. So let's find the area of this figure completely. So first we need to find, so what will be area of the figure is area of figure 1 plus area of figure 2 plus area of figure 3 plus area of figure 4 plus area of figure 5. That's what I have written here. That is the first step. So what is the area of figure 1? Figure 1 is looking like a square. So what is the area of? We know the dimensions of the figure. So 7 units. 7 units is the side of the square. So what will be the area? The 7 sevens are 49. So 49 square units plus figure 2 is again 49 square units. Figure 3 is also 49 square units. Figure 4 is also 49 square units. And figure 5 is also 49 square units. All the squares are of equal dimensions. So I am added 49 square units 5 times because we have 5 figures. Now 5 times 49 when you add, we can write it directly as 5 into 49 square units. So 5 into 49 square units is nothing but 245 square units. So what is the area of this figure completely? It is 245 square units. So did you understand, children? Yes. So whenever you have a figure which is not a perfect square or a perfect rectangle, you can divide that figure into different parts, find the area of each part and then add up to get the area of the complete figure. I hope you understood, children. Now let's move on to the C bit. Now look into the C bit. Yes, it's looking like a shape of a T, letter T. Now I have put a line in between and divided this figure into 2 parts. So now let's find the dimension of this part. So this is one rectangle, this is another rectangle. So this is figure 1 and this is figure 2. Now what is the area of the figure 1? We know that the length of this is 5 units and the length they gave here 2 and this is 2. So what will be this? 2 plus 2, 4. 5 minus 4 is 1. So what will be the length of this line? It is 1 unit. So now 5 into 1 is nothing but 5. So let's find the area of the figure 1. So area of the whole complete figure is nothing but area of figure 1 plus area of figure 2. Now what is the area of figure 1? 5 into 1, that is 5 square units. Now, what is the area of second figure? 4 into 1, that is 4 square units. So together it is nothing but 9 square units. So what is the area of this complete picture? It is 9 square units. I hope you understood this, children. So please practice such problems. It is very important. Is it clear? Now let's move on to the 12th question. How many tiles whose length and breadth are 12 centimeters and 5 centimeters respectively will be needed to fit in a rectangular region whose length and breadth are respectively 100 centimeters and 144 centimeters? That is the A bit, and the B bit is 70 centimeters and 36 centimeters. So now let's do the A bit. Now look into this figure, children. See, this is a rectangular shape that is of 100 centimeters and 144 centimeters. So we can say that this is the rectangular region which is needed, right? And now a tile of length 12 centimeters and 5 centimeters is placed on this rectangular region. So this red color region is the tile. So this tile is placed all over this rectangular region. So do you remember, children? Can you imagine your floor and tiles are placed on your floor, or your walls in the kitchen or in the washrooms? We have tiles placed on the walls. And if you talk about the region in the a rectangular region, whether it's in the floor or a wall, uh, the tiles are placed. So just imagine this is a wall and this is a one tile length which is 12 centimeters and 5 centimeters tile. So this kind of such tiles are placed all over this floor or rectangular region. So how many tiles are needed for that? So what do we know? For this, if you talk about an example, see if I have 100 rupees with me, yes, and I want to buy pen, which is costing 10 rupees each. So to find out how many pens can I buy with 100 rupees, what do you do, children? Yes, you can divide the 100 rupees by the cost of one pen. We can know the number of pens which I can buy with 100 rupees, right? Similar is here. If we know the dimensions of this rectangular region, so can we find the area of this rectangular region? Yes, we can find the area of this rectangular region with the given dimensions. So once we find the area of the rectangular region, and then can we find the area of this tile, that is the space occupied by this tile? Yes. So we can find the area of this tile also. So from the total area of the rectangular region, if we divide the area of this tile, we can easily get the number of tiles required. I hope you understood, children. So what should we do? We should first find the area of the rectangular region, and then we should find the area of the tile. So after finding both the areas, divide the area of the floor divided by area of the tile. So then we will get the number of tiles required. So shall we solve this A bit, children? Let's see the steps. Now, solution. Length of the rectangular region is 144 centimeters. Breadth of the rectangular region is 100 centimeters. So area of the rectangular region is length into breadth, which is equal to 144 centimeters into 100 centimeters. So any number multiplied by 100, we can get the answer very easily. What should we do, children? We have to write 144 and write two zeros at the end, right? So our answer is 14,400 square centimeters, right? Now, length of the tile is equal to 12 centimeters. Breadth of the tile is 5 centimeters. So what is the area of the tile? Length into breadth, which is equal to 12 centimeters into 5 centimeters. You all know the 5 table and 12 table. So what is 12 fives are, children? Yes, it is 60 square centimeters. So now we got the area of the rectangular region. We got the area of the tile. So what is the number of tiles required? So number of tiles required is nothing but area of the rectangular region divided by the area of a tile. So what is it? 14,400 divided by 60. So what is the answer, children? 240 tiles. Therefore, 240 tiles are required to fill this rectangular region. I hope you understood this sum, children. So similarly, you can complete the B bit. Okay, so the area of the tile will be the same as A bit. We need to find the area of this rectangular region with dimensions 7 centimeters and 36 centimeters, and then divide. We get the answer. I hope you all understood, children. So take this as a then complete your mensuration chapter by Monday. Thank you, children. And Monday we will have a cat activity based on the exercise 10.3. So practice 10.3 thoroughly, children. Thank you. Have a nice day.